Class 8, Science Chapter 4, Materials, Metals and Non-Metals. Animated Science, Introduction. We use objects made of a variety of materials every day. For example, utensils made of stainless steel, furniture made of metal and wood, electric wires made of copper, etc. Every material has a specific use depending on its physical and chemical properties. Each and every substance on Earth, including human beings, is made of one or more chemical elements. Based on their physical and chemical properties, the chemical elements are classified into two broad categories: metals and non-metals. In this chapter, we will learn about the physical and chemical properties of metals and non-metals. We will also learn about the various uses of metals and non-metals in our daily life. Metals are elements which can form positive ions or cations by loss of electrons. Example: sodium, potassium, iron, aluminium, copper, magnesium, silver, gold, zinc, etc. Non-metal. Non-metals are elements which can form negative ions, anions, with gain of electrons. Example: carbon, nitrogen, oxygen, hydrogen, etc. Position of metallic and non-metallic elements in the periodic table. Let's understand the position of metals and non-metals and metalloids or semi-metals in the periodic table. Physical properties of metals and non-metals. Physical state. Most metals are solids except mercury, gallium, francium and cesium, which occur in liquid state. Non-metals may be solids, liquids or gases. Solids are carbon, sulfur, phosphorus, etc. Liquid, bromine, gases, oxygen, hydrogen, nitrogen, etc. Metallic luster. Metals have a metallic luster. They have the ability to shine and reflect light. Example: metals such as gold, silver, aluminium, platinum, iron are used to make statues and other decorative articles. Non-metals do not have luster except iodine crystals. Color and hardness. Most metals are either white or silvery gray in color, except gold and copper. Most metals are hard, except potassium, sodium, and lithium, which are so soft that they can easily be cut with a knife. Non-metals are soft, except diamond, which is the hardest natural substance. Non-metals are not malleable. Malleability. The property by virtue of which metals can be beaten into thin sheets is called malleability. Metals are malleable. They can be beaten into thin sheets. Example: gold and silver are the most malleable metals. Hence, jewelry is made of gold and silver. Ductility. The property by virtue of which metals can be drawn into thin wires is called ductility. Metals are ductile. They can be drawn into wires. Tungsten filament is used in most incandescent bulbs. Copper wires are used in the cables which transmit electricity. Aluminium cables are used for transmission of electricity. Non-metals are not ductile. Thermal conductivity. Metals are good conductors of heat. They allow heat energy to flow through them. Example, best conductors of heat are silver and copper. Poor conductors of heat are lead and mercury. Non-metals are bad conductors of heat. Electrical conductivity. Metals are good conductors of electricity. They allow electricity to pass through them. Example, best conductors are silver, copper, and aluminium. Sonority. The property of producing a ringing sound by metals when they are struck with a hard material is called sonority. Most metals are sonorous, except lead. They produce a ringing sound when struck with a hard material. Example, metals like silver, steel, iron, etc. used to make wind chimes, bells, musical instruments. Non-metals are not sonorous. Melting points and boiling points. Metals have high melting points. Gallium and cesium have low melting points. They melt in the palm of the hand. Metals have high boiling points. Non-metals, which are solids and liquids, have low melting points. Non-metals, which are solids and liquids, have low boiling points. Metal plus metal salt gives you metal salt plus metal. Displacement reaction. The reaction in which one metal displaces another metal from its salt solution is called displacement reaction. A more reactive metal displaces a less reactive metal from its salt solution. Magnesium displaces copper from copper sulfate solution. Mg plus CuSO4 gives you MgSO4 plus Cu. Zinc displaces copper from copper sulfate solution. Zn plus CuSO4 gives you ZnSO4 plus Cu. Iron displaces copper from copper sulfate solution. Fe plus CuSO4 gives you FeSO4 plus Cu after 15 to 20 minutes. Reactivity series of metals. The arrangement of metals in the decreasing order of their reactivity is called reactivity series of metals. K. Potassium, most reactive. Na. Sodium. Ca. Calcium. Mg. Magnesium. Al. Aluminium. Zn. Zinc. Reactivity decreases. Fe. Iron. Pb. Lead. H. Hydrogen. Cu. Copper. Hg. Mercury. Ag. Silver. Au. Gold. Least reactive. Displacement reaction, non-metals. Non-metal plus non-metallic compound gives you non-metallic compound plus non-metal. Like metals, a more reactive non-metal displaces a less reactive non-metal from a compound. This is observed in the halogen family, in which F is greater than Cl, greater than Br, greater than I. This means fluorine is more reactive than chlorine, which is more reactive than bromine, and so on. F2 into bracket Aq plus 2Kl into bracket Aq gives you I2 into bracket Aq plus 2Kf into bracket Aq. Reactions of metals with water. The reactivity of different metals with water is different. Metals. Metal plus water gives you metal hydroxide plus hydrogen. Sodium and potassium react violently with cold water to form sodium hydroxide and hydrogen and catches fire. Calcium reacts less violently with water to form calcium hydroxide and hydrogen and does not catch fire. Magnesium reacts only with hot water to form magnesium hydroxide and hydrogen. Metals like aluminium, iron, and zinc react only with steam to form the metal oxides and hydrogen. Metals like lead, copper, silver, and gold do not react with water. Metals react with water to form metal oxides or metal hydroxides and hydrogen. 2Na plus 2H2O gives you 2NaOH plus H2. 2K plus H2O gives you 2KOH plus H2. Ca plus H2O gives you Ca into bracket OH bracket complete 2 plus H2. 2Al plus 3H2O gives you Al2O3 plus H2. 3Fe plus 4H2O gives you Fe2O3 plus 4H2. Non-metals. Generally, non-metals do not react with water, though they may be very reactive in air. Such non-metals are stored in water. For example, phosphorus is a very reactive non-metal. It catches fire when exposed to air. To prevent the contact of phosphorus with atmospheric oxygen, it is stored in water. Reactions of metals with oxygen. Metals. Metal plus oxygen gives you metal oxide. Metals react with oxygen to form metal oxides. When copper is heated, it combines with oxygen to form copper oxide. 2Cu plus O2 gives you 2CuO. The metallic oxides thus formed are basic in nature. Example, when copper oxide is dissolved in water, it forms copper hydroxide, which is basic. CuO plus H2O gives you Cu into bracket OH bracket complete 2. The reactivity of different metals with oxygen is different. Metals like potassium and sodium react vigorously with oxygen and catch fire if kept in open. Hence, they are stored in kerosene to prevent burning. If magnesium is heated, it burns with a bright flame. If iron is heated, it glows brightly. If copper is heated, it does not burn but forms a black coating of copper oxide. Silver and gold do not react with oxygen even at high temperature. Some metals like magnesium, aluminium, zinc, lead, etc. forms an oxide layer over it, which prevents further oxidation. They are called self-protecting metals. Reactions of non-metals with oxygen. Non-metal plus oxygen gives you non-metallic oxide. Non-metals react with oxygen to form non-metallic oxides. When sulfur is heated, it combines with oxygen to form sulfur dioxide. S plus O2 gives you SO2. When sulfur dioxide is dissolved in water, sulfurous acid is formed. Sulfurous acid turns blue litmus red, hence it is acidic. Into bracket SO2 plus H2O gives you H2 into bracket SO3. Reactions of metals with acids. Metal plus acid gives you salt plus hydrogen. Metals react with acids to form hydrogen, which burns with a pop sound. Metals react with dilute acids to form salts and hydrogen. Mg plus 2HCl gives you MgCl2 plus H2. 2Al plus 6HCl gives you 2AlCl3 plus 3H2. Zn plus 2HCl gives you ZnCl2 plus H2. Fe plus 2HCl gives you FeCl2 plus H2. The reactivity varies from metal to metal. For the above metals, the decreasing order of reactivity is Mg is greater than Al, greater than Zn, greater than Fe. Copper, silver and gold do not react with dilute HCl. Hydrogen gas is not evolved when metals react with nitric acid, HNO3, because it is a strong oxidizing agent and it oxidizes the H2 produced to water and is itself reduced to oxides of nitrogen. 3Cu plus 8HNO3 gives you 3Cu into bracket NO3 bracket complete 2 plus 4H2O plus 2NO2. Reactions of nonmetals with acids. Generally, nonmetals do not react with acids. Reactions of metals with bases. Metal plus base gives you metal compound plus hydrogen gas. Most metals do not react with bases. Only a few metals such as aluminium, zinc and lead react with solutions of strong bases, such as NaOH to produce a compound of that metal and hydrogen gas. Sodium hydroxide reacts with aluminium to produce sodium aluminate and hydrogen. 2Al plus 2NaOH plus 2H2O gives you 2NaAlO2 plus 3H2. Corrosion. Corrosion is the damage caused to metals due to the reaction of metals with oxygen, moisture, carbon dioxide, etc. Example: formation of brown coating of rust over iron. Formation of green coating of basic copper carbonate over copper. Formation of black coating of silver sulfide over silver. To show that air and moisture are necessary for the rusting of iron. Take 3 test tubes marked 1, 2, 3 and put iron nails in each of them. Put some anhydrous calcium chloride in test tube 1 to absorb the moisture. Pour some boiled distilled water in test tube 2 and pour some oil over it to prevent air into the test tube. Pour some water in test tube 3. Cork the test tubes and leave them for a few days. The nails in test tube 1 does not get rusted because it had only air and no water. The nails in test tube 2 does not rust because it had only water and no air. The nails in test tube 3 get rusted because it had air and water. Use of metals and non-metals. Metals are hard, rigid, strong, so they are used in making machinery, automobiles, aeroplanes, trains, satellites, industrial gadgets, etc. Non-metals are used to make fertilizers, explosives, crackers, preservatives, gunpowder, etc. Metals uses. Iron. It is used for making objects as small as a pin and as large as a gadget. It is also in conjunction with cement for the construction of big buildings. Aluminium. It is a very light metal, so it is used for making aeroplanes. Aluminium wires are used to making electrical cables. Aluminium foils are used for wrapping of foodstuffs, medicines, chocolates, etc. Copper. It is a good conductor of electricity, hence it is used in electrical gadgets. It is also used for household wiring. It is used for making radiators of automobiles. Magnesium. It is a very reactive metal. It burns in air with dazzling white flame. Hence, it is used in flares, flash bulbs in photography, and fireworks. It is used to line water pipes and tanks as it resists corrosion. Zinc. A coating of zinc is applied to metals such as iron or steel to prevent rusting. Silver. It is used to make coins, medals. It is used in electroplating. It is used in photography. Gold. It is used to make jewelry, ornaments, coins, medals. It is used in dentistry. Fillings and crowns can be molded from it. Malleability. Platinum. It is used to make surgical instruments, chemical equipments, jewelry, etc. Non-metals uses. Oxygen. It is essential for breathing. It is essential for combustion purposes. Nitrogen. It is used as a fertilizer. It is used as a food preservative. It is also used in explosives. Hydrogen. It is used to convert vegetable oil into vegetable ghee. It is also used in fertilizers. Sulfur. It is used as a fungicide and in making gunpowder.